Hi guys, my name is Harry. In this lesson, we are looking into the concept of algebra and geometric sequences. The first question, solve for x. 1.1, we are given x squared minus 2x minus 24 is equals to 0. To solve for x, we're gonna use factorization by finding the difference between the two squares. So the given equation is x squared minus 2x minus 24 is equals to 0. And we know that by the difference between two squares, we're going to have two brackets, and this is equals to 0. And we're going to have our x here, and then we're going to have our x here. And then from here, we're going to choose our factors of 24 in such a way that when we add or subtract these factors, they give us minus 2. Let's start with 3. 24 divided by 3 is 8. So 8 minus 3 or plus 3 doesn't give us minus 2. So these factors don't meet our expectations. Now let's try 4. 6, when we divide 24 by 4, it gives us 6. So our factors will be 6 and 4. 6 minus 2, we can notice that it gives us what? A 2. And when we take 4, we minus 6, that gives us minus 2. So this implies or tell us that our factors that meet our expectation will then be 6 and 4. And then now we have to choose our signs in such a way that when we multiply out the brackets, it takes us back to the original quadratic equation that is given. So we will have a positive 4 here and a minus 6. So we can notice that when we take x, we multiply it by x, it gives us x squared. X by 4, that gives us 4x, minus 6 by x, that gives us minus 6. So we're going to have 4x minus 6x, which is minus 2x. And then lastly, minus 4 multiplied by 4, minus 6 multiplied by 4, that gives us minus 24. Hence, these are the correct factors that we have to use, and how we chosen our signs. It's also correct. We can then conclude that our x is equals to 6, or our x is equals to minus 4. And these are the values of x for that given quadratic equation. Now let's move on to 1.1.2. 1.1.2, we are given 2x squared minus 3x minus 3 is equals to 3, correct to 2 decimal places. So in this question, we have to find our values of x, and our values of x are corrected to 2 decimal places. So it already gives us the idea that we're going to be dealing with fractions. And in most cases, it's difficult to determine the factors when we have to deal with fractions. So the most convenient way will be to use the quadratic formula instead of for difference between two squares. And we know that by the quadratic formula, x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. And then from here, we're gonna find our values of a, b, and c. We know that a quadratic equation has the form y is equals to ax squared plus bx plus c. So from this standard equation, we can tell that our value of a will be 2, our value of b will be minus 3, and our value of c will be minus 3 as well. We can now substitute into the quadratic formula. So this will be x is equals to minus into minus 3 plus or minus the square root of minus 3 squared minus 4 into 2 and then into minus 3. Okay, my handwriting. Minus 3, then divided by 2 into a, which is 2. And then from here, our x is going to be equals to, functional calculator, I'm getting that x is equals to x plus square root of 33 over 4. Now corrected to 2 decimal place, this will be 2.19. And another value of x is 3 minus the square root of 33 divided by 4, corrected to 2 decimal places. This is minus 0.69. And those are the two values of x corrected to 2 decimal places. 1.1.3, we move on to 1.1.3. 1.1.3, we are given x squared plus 5x is less than or equals to minus 4. Sorry about that. Let's continue our lesson. I just wanted to fix a very small error. Now we move on to 1.1.3. 1.1.3, we are given x squared plus 5x is less than or equals to minus 4. Here we are now solving inequalities. We are given x squared plus 5x is less than or equals to minus 4. So we're going to take 4 to the left-hand side. So we're going to have x squared plus 5x plus 4 is equals to 0. We then gonna perform factorization by difference between two squares in order to determine our critical points. I mean our critical values. So the factors of 4 that we add or minus and they give us 5, it's 4 and 1. And then this will be plus and a plus. Hence x is equals to minus 4 or x is equals to minus 1. Now let's graphically represent our problem. So we're gonna have a straight line graph, and then this will be the first point, a straight line, and then this will be the first point here, and then the second one will be here, and then this is minus 4 and minus 1. And then from there, we can see that the inequality signs it's less than or equals to. Therefore, this will be has to be a shaded area. Here in this side, it needs to be a shaded area. So our x, it's basically our graph. It's basically defined on this interval minus 4 between minus 4 and 1. Hence, x will be an element of minus 4 and minus 1 with a closed bracket to show that it is also equals. It is also defined at that point, which are -4 and -1. And this will be the solution to 1.1.3. Now we move on to 1.1.4. 1.1.4, we are given the square root of x plus 28 is equals to 2 minus x. So to solve for this, we're going to square both sides of the equation. So many students make a mistake of when they square both sides, some will square these two numbers individually, which is incorrect. How you square them, it's a whole square like this. Therefore, we know that the 2 will cancel the square root. Therefore, we'll have x plus 28 is equals to 2 minus x multiplied by 2 minus x. Then from here, we'll have x plus 28 is equals to 2 times 2, which is 4. And then 2 by minus x, that will be minus 2x. Minus x by 2, that will be minus 2x again. And then minus x by minus x, that will be plus x squared. Now let's add the like terms. We will have x plus 28 is equals to x squared minus 2 by minus 2, that is minus 4x, and this is plus 4. And then from here, we're gonna have 0 to be equals to x squared. Now we take 20x to the other side. So this is minus x, that will be minus 5x. And then we also gonna take minus 28 to the other side. So this is 4 minus 28. 4 minus 28, which is minus 24. Now let's go ahead and factorize. This is equals to 0. We're gonna have x, and then our factors will be, when we take 24 and we divide it by 3, it's 8. 8 minus 3 is 5. So we're gonna have 8 and 3. And then the signs, we're gonna have plus and a minus. So 3 minus 8, it's minus 5. And then minus 8 times 3, it's minus 24. Perfect. Therefore, our x is equals to 8, or our x is equals to minus 3. Now let's go and substitute into the equation and see if these values are correct. So the square root of 8 plus 28 gives us 6, and then 2 minus 8 gives us minus 6. So 6 is equals to minus 6, so which is incorrect. Therefore, this tells us that x is not equals to 8. Now, let's check with minus 3. The square root of minus 3 plus 28 is 5. And 2 minus into minus 3 is 5. 5 is equals to 5, which is correct. Therefore, these will be the final answers for 1.1.4. Now, let's move on to 1.2. 1.2, we have to solve simultaneously for x and y. In the equations, 2y is equals to 3 plus x, and 2x plus 7 is equals to x squared plus 4y squared. Let me change the settings. Okay, we are given the equations. 2y is equals to 3 plus x. We can call this our equation 1. And then we are also given 2xy plus 7 is equals to x squared plus 4y squared. And then we can call this our equation 2. Now we're going to create equation 3 from using one of these equations. So I decide to use the first equation since it's more convenient. So from the first equation, I'm going to get that x is equals to 2y minus 3. Then this will be my equation 3. Then from there, I'll substitute equation 3 in equation 2. So that is going to be, let me open another page. Perfect. Let's substitute. Let me use black. We're gonna have 2 into our x, which is 2y minus 3. 2y minus 3. And then this is multiplied by y plus 7. And this is equals to x squared. We substitute our x, which is 2y minus 3. And then this is squared plus 4y squared. Now let's multiply out the brackets and solve. So we're gonna have 2 by this, y by this. So that will be 4y squared. And then 2 by 3, and then y by minus 3, that will give us minus 6y plus 7 is equals to, this is the difference between two squares. You're going to have 2y multiplied by 2y, which is 4y squared, and then 2 multiplied by 3, it's minus 6 by minus 6, this will give us minus 6y, and then minus 3 multiplied by minus 3, that will be plus 9, and then this will be plus 4y squared. And then do we have like terms? 4y squared will cancel 4y squared here. You can notice that. And then we're gonna have 4y squared, and then minus 6, when we take it to the left hand side, will cancel with the minus 6y. And then we have 7, we take it to the left hand side, will be minus 9, and that will give us minus 2 is equals to 0. Then from here we'll have 4y squared to be equals to 2. Therefore y squared will be equals to 2 over 4. Hence, our y will be given by plus or minus the square root of 2 over 4. And then as such, our value of y is going to be square root of 2 over 2, and y is equals to minus square root of 2 over 2. And the corresponding values of x will be, remember our x is equals to 2y minus 3. So where y we substitute 3, so we're gonna have 2 into our y, which is square root of, our y is square root of 2 over 2. Minus 3, and that gives us our x value to be minus 3 plus square root of 2, and then the other x value, we're gonna substitute minus, right? And that gives me minus 3 minus square root of 2. Okay, now let's go and substitute into our original equation to see if these are correct. I'm gonna start with the y square root of 2 over 2. 2 into square root of 2 over 2, that gives me square root of 2. Is it really indeed equals to 3 plus minus 3 plus square root of 2? Yes, it's square root of 2, so that is correct, because 3 will cancel with minus 3, which is a 0, right? So that is correct. And then using the other values as well, get square root of 2 over 2, then that gives us minus square root of 2. And then even this side, we can see that 3 plus minus 3 minus square root of 2. 3 cancel with minus 3, then we are left with minus square root of 2. So that is correct. So you can do the same with the other equation. I believe that we'll get the same results. Then you can also round off these final answers to 2 decimal places. So this will be 0.71, and this will be minus 0.71. Minus 3 plus square root of 2. In a decimal place, this is minus 1.59, and then the other one is minus 4.41. And that is those are the solutions to 1.2. Now let's move on to 1.3. 1.3, the question says the roots of an equation are x is equals to minus n plus or minus the square root of n squared minus 4np all over 2m, where m, n, and p are positive real numbers. The numbers m and n and p in that order form a geometric sequence. Prove that x is non-real. So now we are given the roots of an equation for x, right? And we can see that these roots have a form of a quadratic equation. And now we are required to prove that x is a non-real. So from our quadratic formula or equation, we know that x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay. On this quadratic formula, the value b squared minus 4ac, it's what we refer to as delta, and it is represented by this triangle symbol here. It is known as delta. So in order for your roots to be non-real, this value of delta, which is equals to b squared minus 4ac, should be less than 0. Okay. The reason being that if your b squared minus 4ac is less than 0, then on your quadratic equation, you'll have x to be equals to minus b plus or minus the square root of a negative number, where a can be any real number, right? All over what? 2a. And we know that the square root of a negative number is what is undefined, right? Therefore, if for us to prove that x is a non-real, because if for your solution is undefined, then that means x is what? That number is it's a non-real number. So therefore, if we can prove that our our delta is less than 0, then we have then indeed shown that x is what? It's non-real, since we're gonna have a square root of a negative, that is, which leads us to an undefined answer. Now let's continue. So from this definition, this tells us that from the root of our equation, we have x to be equals to minus n plus or minus the square root of n squared minus 4 mp all over 2a. So from this knowledge, we can tell that if we can prove that n squared minus 4mp is less than 0, we have indeed shown that x is what? Is an unreal number. So how are we going to go about proving this? That n squared minus 4mp is less than 0. We're going to use the concept of a geometric sequence. We are being told that the numbers m and p are positive real numbers. And we are also being told that m, n, and p in that order form a geometric sequence. And we all know that by definition, a geometric sequence is a sequence whereby the the consecutive terms have what? Have a common ratio, right? So they say they form a geometric sequence in this order: m, n, and what? And p. So that means these are the first three values in our geometric sequence. So m, n, and p are positive real numbers. So they can be any any value that is positive and it's a real number. So by definition, a geometric sequence is a sequence whereby two consecutive terms have what? Have a common ratio. I can give you an example with this sequence. Let's say 2, 4, 8, 16. We can notice that when we take 4 and we divide it by 2, we get 2. When we take 8, we divide it by 2, we get 2. When we take 16, we divide it by 8, we get what? 2. So from this sequence, we can notice that the two consecutive terms, this and this, and then this and this, have a common ratio of what? Of 2. Okay. So as such, we are going to have the same pattern even when we are given variables, right? So by definition, we can conclude that m over n over m is equals to p over n, because this is a geometric sequence, right? And a geometric sequence, two consecutive terms have a common ratio. So when you take the value of n and you divide it by m, it will give you the same value when you take p and you divide it by what? By n. Then from here, we can then solve by cross multiplication. We'll have n squared to be equals to p m, right? So, and previously, we were supposed to prove that 4n squared minus 4mp is less than 0. So we can notice that we have the value of n squared, which we found to be the value of n squared, which is found to be pm. So where there is n squared, we can substitute pm. So this will be pm minus 4mp is less than 0. So pm minus 4, this will give us minus 3 MP is less than 0. Now, for the fact that M and P are positive real numbers, okay, are positive real numbers. That means both M and P are greater than 0, right? So any positive value of M and any positive value of P that we substitute and multiply by -3, it will always give us what? A negative number. So since that is the case, we have then indeed proven that x squared minus 4 MP is less than what? 0. Okay, so that's how we go about proving that x is a non-real number. Alternatively, you can also use n instead of what? Of MP. So by doing so, where there is MP, you substitute what? N squared. So you're gonna have n squared minus 4 into MP, which is n squared, is less than 0, right? And then from here, n squared minus 4n squared, that will give us minus 3n squared is less than 0. N is also a positive real number. So any positive value of n that we substitute here will be a positive. And when we multiply it by this minus 3, will always be a negative. Hence, you're going to have a negative. We can say a is less than 0, where a can be any value that for when we substitute the positive real numbers for a, we multiply by -3, it gives us that value. Okay, but this is unnecessary, right? So in this case, you have proven that your x is indeed a non-real number since your delta is less than 0.